Clear roadmap for today. We'll start with the role of database keys, then hit core identifiers like primary and candidate keys. From there, we'll expand into super and alternate keys, see how we link data with foreign keys, combine columns for composite keys, and finally, wrap up with why all of this matters so much.
So, starting off with Section 1, the role of database keys. I want you to imagine a massive data lake. It's ingesting millions of unstructured data points every single second. Without a really rigorous architectural framework in place, trying to query that data is, well, functionally impossible. It would literally be pure chaos.
And that brings us to a really fundamental architectural question. How do we properly organize and connect millions of database records? I mean, when you have tables packed with thousands or even billions of rows of information, how does the system know, mathematically speaking, which exact row belongs to you?
Well, the answer lies in database keys. Simply put, these are the strict tools used to uniquely identify, organize, and connect records properly inside a database table. Drawing straight from our source, keys help us organize, connect, and identify data with absolute certainty. Without them, managing relationships between your data tables wouldn't just be a headache, it would be practically impossible. Moving right along to Section 2, core identifiers, specifically primary and candidate keys. This is where we make sure every single record in our database gets its own unique mathematical fingerprint. Let's look at the primary key. It's simple, but it is incredibly strict. Think about a basic table with student ID and name. Rahul is 101, Aman is 102, Priya is 103. That student ID, that acts as our primary key. It's used to uniquely identify each individual record, and it comes with two golden, unbreakable rules. First, absolutely no duplicates. Two students cannot be 101. Second, it cannot be null. Every single student has to have an ID, no exceptions. But what happens when we have more than one valid identifier? Say we introduce an email ID into the mix. Both the student ID and the email ID can uniquely pinpoint a student, right? No two students share a student ID, and no two students share an email address. Well, when multiple columns have the power to uniquely identify a record, both of these are considered candidate keys. Basically, they are both totally valid candidates for the top job.
So the crucial point is really understanding the relationship between these two concepts. A candidate key represents the multiple possibilities that could become the primary key. But while a table can have tons of candidate keys, only one is ultimately selected by the database designer to act as the official primary key. It's exactly like an election. You have lots of candidates running, but at the end of the day, only one actually wins the office.
That takes us right into Section 3, expanding identifiers. What happens to the candidates that don't win? And what if we look at multiple columns at the exact same time? Let's talk about super and alternate keys.
First up is the super key. Now, a super key is a set of one or more columns that can uniquely identify a record, but, and here's the catch, it might contain extra attributes that aren't actually necessary for uniqueness. For example, student ID uniquely identifies a student, for sure. But student ID plus name also uniquely identifies a student. Even though the name is technically extra, unneeded information for identification, the combination as a whole is still mathematically unique. That entire combination is a super key.
And this creates a really fascinating hierarchy in database management. A candidate key is your minimal unique identifier. It's lean. A super key, on the other hand, is a unique identifier that might be carrying some extra baggage. Because of this, all candidate keys are technically super keys. They do get the job done. But not all super keys are candidate keys, simply because they might have those unnecessary extra attributes tagging along.
Okay, so what about our election losers? The valid candidates that just didn't get picked to be the primary key? We call those alternate keys. If student ID wins the primary key spot, the runner-up, like our email ID from earlier, officially becomes the alternate key. It's still completely unique, it's still highly important, it's just the alternate.
Now for Section 4, linking data with foreign keys. Up until now, we've really only talked about single, isolated tables. But the true power of a database, that's in how tables talk to each other.
And this brilliantly illustrates how we actually bridge data silos. Let's walk through it together. Step 1, we have our student table with its primary key, the student ID. Step 2, we have a completely separate course table that tracks classes, but obviously it needs to know mathematically who is enrolled. Step 3, we take that student ID and add it into the course table. Because the student ID is natively from a different table, it acts as a foreign key inside the course table.
It connects the two tables, creates a relationship, and absolutely crucially, it maintains data integrity across the whole system.
Moving into Section 5, Combining Columns for Composite Keys. Sometimes real-world data modeling just isn't as simple as having one perfect ID column.
Think about an enrollment scenario. A student might take multiple courses, right? So the student ID alone is going to show up multiple times. It's going to duplicate for every class they take. That means it can't be a primary identifier on its own. And a course ID? That's going to duplicate for every single student sitting in that room. Neither works by itself. So what do? We form a composite key by combining them. Student ID plus course ID. Together, they form a totally unique pair that perfectly identifies one specific enrollment record. When one column isn't enough, we combine them to get the job done.
Finally, we arrive at Section 6, Why Database Keys Matter. We've defined all the major players, so let's step back and look at the big picture. Why are these so vital to the infrastructure of the internet?
Let's move to a quick recap and see how this all builds together. Just to lock this in, the primary key uniquely identifies records. The candidate key is a possible primary key. The super key is unique but might have extra attributes. The foreign key is what connects our tables. The composite key is a combination used when one column isn't enough. And the alternate key? That's just the runner-up candidate. The reason database architects obsess over getting this stuff right is because these keys are quite literally the backbone of a healthy system. They maintain uniqueness so your data doesn't corrupt. They actively reduce duplicate data, which, by the way, has historically saved massive enterprises millions in server storage costs alone. Plus, they create the actual structural relationships between tables, drastically improving the overall speed and performance of database queries.
And look, this isn't just academic theory. Keys govern the systems running our everyday lives at a massive scale. When you check your bank balance, your account number is a key acting against millions of concurrent transactions. When a hospital database pulls up your critical medical history in milliseconds, or when your favorite e-commerce app processes your shopping cart, every single one of those actions relies entirely on the mathematical certainty of these exact database keys to function.
Which leaves us with a really fascinating, provocative thought to end on today. We now know that keys are the essential tools to organize and connect data. But honestly, just having keys isn't enough if the tables themselves are poorly designed. So how do we structure our tables from the ground up to ensure the data inside them is completely free of errors and anomalies? Well, that process is called normalization, and it is the absolute perfect topic for you to explore next. Thank you so much for learning with me today on The Explainer. Keep analyzing, keep learning.